802.11ax, Wi-Fi 6. It offers a beautiful story that says that all these little IoT clients with little data will be simultaneously connected with those high-demanding clients with virtual reality and augmented reality. And on top of that, we have support for, or extended battery life support for smartphones. How do we get to this? Well, it is just by applying existing functions and features into Wi-Fi. We have downlink and uplink, multi-user MIMO support, OFDMA, coloring of BSS, we have target wake times, and we have support for longer symbols and longer timing intervals for outdoor connections. Let me try to explain them one by one. Multi-user MIMO. Remember from my previous video, in Wi-Fi 5 we have in the downlink multi-users that will be supported simultaneously. This is downlink multi-user MIMO. This only happens in the downlink. If the user wants to send something back, it all happens one by one again. So we're losing spatial stream information. So with the support of downlink and uplink spatial stream, we have this benefit in both directions. This requires Wi-Fi 6 access points and Wi-Fi 6 clients. OFDMA is all about the truckload. Remember this truckload, this binding of channels, so channel bonding. We will send, let's say, up to 4 different packages at once to our clients. But if it concerns an IoT client with only some temperature reading, it's not going to send a full truckload of content. It only sends a little package of information. This means that our truck is almost empty. With OFDMA, orthogonal frequency division, multiple access, we allow multiple clients to access this truck simultaneously. So each packet will be assigned to a specific user or IoT device. But what if it's just sending some readings of data? That doesn't really, it's not really using a full 20 Hz megahertz channel. So it maybe only uses 2 megahertz at once. With this in mind, we can support up to 9 of these IoT clients simultaneously in one single box. So we're not using the full spectrum of frequency, so not all the different colors will be used to send one box of information. One monotone coloring will be used for one transaction. So we can use up to 9 clients simultaneously within one channel or one box of information. And if you're using channel bonding, obviously you will support tens of clients simultaneously with this feature. The other thing is OBSS. It's overlapping basic service sets. This means that do you hear that too? That is exactly how access points behave. If there is another access point saying something next to them, they will stop with their conversation because this can be a transmission for them. With OBSS, the access point and the clients will be coloring their unique transaction with one color, a unique color. So if I receive information with the color blue, I know it's for me. And if I receive packets of information with the color green, I know I can discard this from a certain threshold because it's not for me, it's intended for another access point. This increases, of course, the performance in the Wi-Fi. The other thing is laying the full power to the access point, so orchestration. In this way, we can step away from what Wi-Fi used to be, because a smartphone is always connected with the Wi-Fi, right? So it's always listening when there is a free moment to send something. So this means that the clients are having to do a lot of listening before sending something. With target wake time, the access point will say to the clients when they can send some packet of information. This is opening up a lot of free airtime because we have a lot less collisions over there. And an additional benefit, which is also kind of cool to tell, is that those clients will be put into rest modus when they do not send. And when it's their turn, only then the radio or the antenna will be turned on. So we have a better Wi-Fi or a better, well, less collisions, less interference, and we have an increased battery life. For outdoor environments, so yeah, this was a target wake time, just in between. Specifically for outdoor Wi-Fi networks or environments, we see that there is a lot of reflection of our wireless access point to the clients. So this means that if we're sending a little bit of information and it reflects to the walls or to other objects, this object will come into the access or into the client 2 times. So if one signal is short enough and it bounces off and comes in, the client thinks this signal is sent twice. So specifically for outdoor networks, it makes a lot of sense to have longer signals. This means a longer tone on the telephone, a touch tone telephone, for example. If you touch on the phone, you hear a sound which is doot. Remember, if it is long enough, then this symbol will still be receiving before reflections will come into the client. So this means that the client is 100% sure that those reflections are reflections and they can be discarded. And on top of that, we can of course also add additional guard intervals before we send out new packages. So all of these features, not really new features, but proven technologies into our new Wi-Fi 6 network, we can increase the performance, increase the efficiency, and have less interference. On top of that, because the air is much cleaner now, we can start thinking of increasing our quadrature amplitude modulation structure all the way up to 1024 in some cases, if there is enough free space in the air.